Hello everybody, hello from your favorite artist electronist, Mr. Q12 here. And I made a fantastic progress for the glory of Q12 Imperium, for the greatest emperor, Mr. Q12. So I managed to make multiplexed LCD work by bit banging the pins of this one, HT1621. Let me find. So actually I made this file today on 21 of 12 of 2024. This is the IC that I'm using, and that I'm having it for quite a long time, and I didn't know how to drive it correctly, and I tried multiple times, and actually I managed to drive it, but using an Arduino library, very specific library, and that you could not do too many things with it. You only could send numbers, and that's it. You couldn't manipulate the segments, individual segments of the LCD. Or maybe you could, but I didn't know how. So it was very strict, and me personally, I like to dance around and to have a lot of freedom of a lot of liberty of expressing myself with anything that is hardware, pretty much. So my intention, this was my dream for a very, very long time, for a couple of years, when I put in my mind to actually drive this multiplexed LCD type. And many like this are out there that are multiplexed, and they have this duties and bias driving method, and etc. The easiest to drive is this static LCD, and it's very, very easy to drive. I actually drive it using logic ICs. I have the project somewhere out there, and I made a couple of movies about it, how to drive it. So these are this type of LCD. Actually, let me show you a couple of these are the specifications for it. So this is static. You see here in the title, static positive display driving at 3 volts. This is the size of it, blah blah blah. And it's quite big, and it's having a lot of pins. Why? Because it is driven in parallel. You are sending a signal per each pin, and you are lighting up one segment, and it's very, very easy to drive. And here I colored the exact location of each pin and what it's doing, and I color coded it myself. I took this, I downloaded it from internet, from the seller page. This was the original, which was black and white, and you see, and I made it cooler. I made it better. So it's good to take them out and to tweak them yourself. And this is a 4-digit LCD, and it's static. But this entire movie, what I'm showing you here, is not about this static LCD. I'm telling you that this is extremely easy to drive, very, very easy to drive. You can do it even with logic ICs. You don't even need a microcontroller for it. Or if you want a microcontroller, you will have to multiplex 1 or 2 pins from that microcontroller, and Bob's your uncle. You are doing the business. You can drive it fully. And it's that easy. It's literally that easy. And actually, I love this parallel driving. I always said this detail about parallel driving. It's very, very user-friendly. It's very intuitive to drive. I just love it. So that's all about it. Now, about this motherfucker. This motherfucker is serial-driven. It's not parallel-driven. And being serial, let me actually show you some data about it. This is also, I took it out and I colored it myself. And these are the COM pins here, 7, 8, 9, 10. These are important pins. And also, so these two guys are driving this digit. These 2 pins are driving this digit. And these 2 pins are driving this digit, but in conjunction with all these common pins. So there are 6 pins per each digit to drive it in total. So it's not about how to drive it. It's literally how to link, how to make the connections to it, because this was a discussion that I did it another time. And in another movie. So this is the difference between these 2 types of LCDs, all right? And the idea is that it's very, very hard to drive it. And for a very long time, I tried to drive it, and I couldn't. And I had this IC, specifically, I buy it to drive this type of LCD, this multiplex LCD, but because it's doing internally a lot of important switching between those COM pins and those segment pins for each digit, and it's doing it internally, and you have to drive a little bit more, theoretically, a little bit more easily through this chip, that LCD. So I tried to bit bang it myself, but I couldn't. So this page that you are seeing here is, this part is about this LCD, how many digits it's having, and I color coded them. This part here is about this LCD driver, and this is its internal memory that you are writing in code, in Arduino code. When you are bit banging, you are writing to these addresses, and to these bits you are filling them up with data, and you are changing all the segments for digit 1 in blue, in green for digit 2, brown on digit 3. And it is having 31 addresses. So it is having actually space, or all these pins that is having, you can link to 16 digits. So if you have a larger display than this with 16 digits, you can actually drive all these 16 digits from that display, not counting the points or double points that is having there, probably so less than 16 digits. Actually, if you have to drive some dot points, between the digits, you will have less digits to drive with. But even if it's so, you have a ton of digits to drive from only one chip, and it's glorious. It's very, very interesting chip. I really like it from the beginning, and more than this, it's extremely cheap, very, very cheap. And I have, I believe, 10 of them. And I never managed to drive an LCD except that specific library that I mentioned already, except that. But I didn't like it. I mean, it was nice that I could do it. It was very nice, but I didn't like it because it doesn't offer me too much liberty. And I will show you, I will prove you what liberty means, what real freedom means when it comes to driving an LCD, especially through BitBanging, as I was hoping to manage to do it. And I'm beating this problem. I'm trying this thing for a couple of years actually, but I leave it aside because it was too hard. I tried to hack some libraries from Arduino and I couldn't understand how to do it. I managed to crack a good part of them, good percentage of them. I could understand what they were doing, but I was choking at some points and I couldn't get past over that. So that's it, game over. For a couple of libraries, it wasn't only one or two, it was like 3 or 4 libraries, I believe. I fully concentrated days, like many hours I spent to try to crack those libraries, and I couldn't. I just, I just stumbled over some very, very high level of programming that it was over my ears, and I give up, And I leave this problem on the table for this setup that you are seeing here. Actually, let me show you a picture. So this is the setup that I'm having on my table right now, but this exactly this setup that you are seeing it here, I was having it 1 year ago when I tried desperately, I may add, to crack those libraries to make it possible to BitBang it. I managed to work it with this setup that you are seeing it here with that library, so that was a step forward, extremely important for me to reach. So that was phenomenal. That was great, really great. But after that, I wanted more. I wanted this BitBanging procedure. And I was after it for a very, very long time, like I said. So this was the setup that I had it 1 year ago. I just leave it somewhere on my other table, and it catched a lot of dust on it. And I was looking from time to time, and I was afraid to restart this project again because I knew it was too freaking hard, too freaking impossible, at least for me alone to do it. Yesterday and today, I stay over it, and I had the inspiration to put more better questions. I was discussing this problem in the Arduino forums. Some guy from there, he did give me some hints. He didn't actually help me like putting it in my bag. He only said, take this code and make it work. Pretty much it was like that. And I stayed on that code, and I did make it work. Let me actually show you. So these were the beginnings. Yes. So these were the errors in the very first tries. When I was using his code, I was getting these very different symbols, if you want. Here on this LCD display, I was getting these characters, these segments open up. When I wasn't sending anything, I was having it blank. And when I was sending one here, I was getting these 2 guys. When I was sending one, I was getting 3 segments open, lighting up. And when I was sending all 4, I was getting this A letter like. And when I was sending only 3, I wasn't getting any changes from the previous state. So this was the initial errors I was getting using his code. But the good thing that I observed and that I jumped onto was that I was finally getting some results, getting some segments lit up, literally through BitBanging from Arduino through these wires, commanding this chip that it is commanding the LCD. So that's the hierarchy of doing things. I was not using a library, I was using literal BitBanging. And I will show you right now, I have it here. Let me actually show you the structure of what I had until now. So this is my folder, Electronica, Proteus, Save, and here I have display, and I have 7 segment displays which are with LEDs. Let me show you one to know what I mean. So this kind of common cathode, common anode displays. And here I have the LCD. Inside this LCD, I have this multiplex and static. And like I said before, this static LCD, I made a couple of movies about it, and I explained everything, how to drive it very, very easy. This is Dave from EV blog, and he is explaining this little theory, how to drive it using SOR gates, the frequency of 100 hertz there. And I took it to heart. I truly believe him. And I managed, based on that theory, I managed to drive, to make this simulation that you are seeing here, and then to drive the actual thing. So I managed to drive this very, very easy to drive it. Here you see this static, which is extremely easy to drive, and this is multiplex. And inside this folder multiplex, and here is the entire list of tests that I did when I tried to hack those libraries before. And this is actually the original code. This is how simple it is, very, very extremely simple. You see, this is the library, and I run this code, and it will show you a result. Very easy code, very easy to do, but it's very limited. You can only drive numbers, and that's it. No custom shapes or individual segments, like I said. So this is the old stuff, and this is the beginning, LCD B1. This is the very first test that I did to actually understand how to drive each segment. This folder here, B2, is where I'm making numbers, and I'm driving those numbers. And here, this B2B, B2B, this is the simplest, is this file that you are seeing here. You can see it here in the name, LCD B2B. So this is the, you can actually read here, most basic segment driver. So this is the most basic way to do it, and this is how it's comprised of. This is the program, this is how it's structured. I'm declaring originally, if you are seeing here, I'm having these two pins from pin 0 and pin 1 from the Arduino Uno ER tray. I was getting these two pins onto that board. So later, after discussing with my Arduino friend there, he suggested to me to change from these two pins, because these two pins 0 and 1 are connected directly to USB interface here. But after this guy told me to change, then I changed it. So this is the new pinout that I used, and I will show a picture of it, how it is looking right now. It's not like here, is a little bit different. So it's starting on pin 2, which is this one here. So 0, 1, 2, 3, 4, 5. You see, 2, 3, 4, 5. This pin I'm not using yet, this read. I'm only using data on pin 2, write on pin 3, and chip select on pin 5, and that's it. Only these 3 pins. This read and IRQ, I don't use them, but I leave them there. Maybe I will use them someday in something that is way more advanced than what I just managed to do right now. What this data, write, read, and CS means is these pins that you are seeing them, they are linked to those on the breadboard. And this 2, 3, and 4 is the Arduino pins. So this is what it means, what I'm having there. And this is how I linked everything in the very beginning. Later, I changed these 2 wires from here there. I will show you a picture about it. But this is the most important thing here. You can see the pins, data pin from this chip to Arduino pin 2, 3, 4, and 5. This is the corrected pinout on this diagram that I'm having here, how I linked everything myself. This is the wiring that you are seeing in this picture. You can see from these segments here, segment 0, 1, 2, 3, 4 to change. You can see these yellow wires that are going into this LCD, and these red wires are coming from here. So this is the top of the IC, and this is the key top of the IC. It's pretty much like this. You see, the chip that you are seeing here in the picture is in this position. This is a voltage regulator, LM317, that is transforming from 5 volts. You can see here these 2 alligator clips. This is a positive rail, and that's negative. I put a very good distance between them, not to make a short. And this voltage regulator is actually regulating to 3 volts for exactly this VLCD pin, that it needs this 3 volts and not higher voltage. And the voltage for this IC is coming from the grounds are connected together. So this is positive link, and this is the negative link. So this is negative link, which is this VSS on pin 13, and positive link is this plus 5 volts. That is coming actually from this power supply from here, and then it's transformed. This 5 volts is transformed. So this 5 volts is powering this chip, but in the same time is transformed into 3 volts, and this green wire is the 3 volts that is going into this pin 16, necessary to power this LCD, and that's it. And from the 5 volts, I'm actually having a small little lamp that I made it from a piece of wire and a little bit of plastic that I melted, and inside is a LED, high power LED actually, and a resistor, 1 kilo resistor or something like that, and it's powered through these 2 legs on positive and on negative, and that's it. So this is the wiring, and I didn't connected any other segment pins like here up to address 31. You see all the segments to 31 segment. So starting to segment 0, which is address 0 here. So for each pin is an address of 4 bits pretty much. That's the whole shebang of it. And here are the settings pins, and also here another setting pin, and it also is having a buzzer option. You can link a piezoelectric buzzer. I am thinking of it. I'm planning to add a buzzer to it to actually buzz something. One frequency and another frequency, and they are fixed. You cannot change them. And this is external oscillator, crystal oscillator, and drive everything from outside, but is also having internal oscillator, and I'm using that internal oscillator. Internal RC oscillator, I'm not sure, 250 kilohertz. This is the command to actually use its internal oscillator. And here another command to actually turn on system oscillator, and I'm not internal RC. I'm not completely sure why these 2 are used. That's probably one of the problems I had before when I was trying to run it myself, and I couldn't. And this is the actual declaration of what pins I'm using, and I'm setting this as outputs here in config, and this is a function and an outside function from the main program, and this is where I'm setting these 3 pins as output. So this was the first step to do it, and then I'm setting them as high, and then this is actually his code, my friend from Arduino. He literally gave me these pieces of code, and I had to put them together and to adapt to what I'm having here. And it wasn't that much to adapt, but it was a little bit to think about. It wasn't easy as copy and paste. It was a little bit of thinking, but I did it relatively quickly, let's say in a couple of minutes. Shift out bits. This is a function that he gave it to me. This is his function. This is another function, send command, that I'm not using. It is only used here in this configuration for setting this chip with special settings, to set it up to a special configuration, to start in a certain way. And before this, when I was looking in those other libraries, when I was hacking them, I did see these numbers and also these comments, what they mean, but they were a little bit different from what we are having here. This send command is way more practical to use it than declaring these bits and then dealing with them. Probably it's the same thing, but from my experience that I'm having right now with all this code, is better to have this send command that is making use of those bits directly. It's easy. It's way more easy. This shift out bits is used inside this send command, and this send command function is used here in this configuration, and that's it. All these first three functions are not used in the rest of the code. That's it. They are declared here. Only this configuration is used here in the main setup when you are starting the program. This is the first function that is the program is starting with, and I'm declaring this config function, as you can see from here. And then this is the most used, and this is the most practical function that I use it everywhere pretty much. So all this code from here to here, this is what my friend from Arduino gave me the first round. The first thing that he gave me, it was all this code, and I had to make it fit with what I was having. So I had only this setup and this loop, and I didn't know what to do with that things, and I didn't understood what they are doing. But then after reading where they are fitting, where they are used, like this shift out bits is used here in this send command, and this send command is used here in this configuration, and then I said, aha, so these bits that I've seen them before in those other libraries, I recognize them. I understood these are settings for the ICs. So that's it. I named this function as config, and probably is not a good name because I'm having this config is this color, orange color. Probably I should have name it a little bit different to be black, not orange, but it's working. So it is interfering actually with something from inside Arduino. I have no idea what, but it worked so far, so it's good. It's fine. Like I said, this send data is the gold function that is actually doing all the BitBanging. We are doing the BitBanging with this function. And here, after playing around, after understanding how to use this send data, pretty much you can read here. You have to input an address and you have to input a value, like I showed you here. So this is what I understood when I seen this function. This address is these 2 lines, some of these lines, because at the moment I didn't know how the structure was, and then I realized it's actually only 4 bits and an entire column of 4 bits lines. And then I started to play around using only this simple function, like you are seeing here, like this. This is the address that I'm getting that EXA. It's a bit hard to explain it simple. So I don't know how to explain it better than this, because here is a little bit more complicated. So I made this address array. I write them by hand, everything you are seeing, and I numbered one by one myself. So this is bit 1, this is bit 2, this is bit 3, this is bit 4, and so on, until 32, I believe is this. Actually, I made this address way more longer than this. I made it as 64 because I didn't remember at the time. I was concentrating on how to do it, so I wasn't concentrated how long it was. But then later I opened up the PDF and I realized it's actually having only 31 addresses. Actually, from address 0 to 31 equals 32 addresses. So that's why I'm having this array starting from address 0, which is this, and ending at the last one, which is 32. So I made an array that is holding all this data and is not modified. I'm only reading from it, and that's it. It's read-only. This thing is read-only, and that's it. As this one as well. This other array is also a read-only array. Actually, you can read my notes that I leave there, and they are very more explicit. They are explaining what the hell these arrays are doing and used for. And then this is a clear function. This is what it happened in reality after you write an address. After you write some bits in this address, in this memory address, those bits, they become a segment on your digit, and after you are switching to other address, the previous segment remains there if you don't clear it. So this is very important function here to clear every time after you use an address and use the bits on the address and you lit up that specific segment, you clear it, not to remain, not to ghost there, not to remain like a ghost there, you know, to actually create a normal and clear switch between one number and the other number. Other way, if you are not clearing and if those segments remain, it will not look like a normal number, it will look like gibberish pretty much. So this is very important. And this is I had some problems with this clear. I actually made a very bad clear function that was actually clearing the entire LCD. It was clearing it, it was making it blank, absolutely, but it was completely wrong, completely fucked up. It was jumping some addresses. I have no idea how it managed to clear up the entire LCD, but it did it. So in a sense, I had a lot of luck to use that fucked up, very wrong, very bad clear function in the very beginning, and then after I figured out how the structure is, then I came back and I remade it as you are seeing it here, very, very specific and very efficient. This is extremely efficient and is not beating the bush. It's just doing its job specifically where it's needed. You know, it's directly where you need to clear. Pretty much on all these 6 addresses that you are seeing here, is clearing each address one by one because it's having only 6 to count, and that's it. It's that simple. Before I was using a way more larger. I was using 64, if you remember. I used here 64 and I was clearing all 64 addresses. God knows what it was doing inside it. So that's the clear function, which is very clear right now, okay? Here I made a number 8. This is the digit. This part is the digit. If I want digit 1, digit 2, or digit 3. And it's having a special way of using. As you can see here, for digit 1, you use 0 here. You see? You are using 0. For number 8, let me show you. So we are having this is digit 1 on the right side, okay? So to actually lit up, to make it as an 8, like you are seeing here in the pictures, to make this 8, you are putting this N8, which is this function here, with this 0 here that it represents the first digit. Then, if you want the second digit to lit up, you are using 2 instead of this 0. And 4 instead of this 0 if you want it on digit 3. So this is clear as mud. I know it's a little bit weird how you have to declare it and to use it, but in a sense, once you get used to it, it's very easy. It's quite easy to use it. And number 8, N8, this N8, it means what number it should display there. But this is a little bit more advanced. Like I said, if you are seeing the structure here, this is actually the first folder with the very beginning stuff, which is mumble jumbo. That's why I'm not showing you anything from there, because it's a lot of bad code inside, pretty much, until I refine it very well here in this second folder. And this third folder is actually containing this single file, which is this one that we are discussing right now, because it's cleared up. That's why I'm using it. So this is from here, from my second folder, where I used these numbers. I already mapped exactly all these segments. So this A, you see here, this A, it means this A segment there. B and C is this B and C. So A, B, C, it forms number 7 here. You see, the first address, and it's here on this address, on address 0, on this 4 bits. And this bit here doesn't matter what it is. If it's 0 or 1, it doesn't change anything. So this is unusable bit. It's just blank, and that's it. You have to get used to it. And then these other 4 bits on address 1, this one, as you can see here in the function, if I'm inserting there 0, this is 0 plus 1, and it means this is address 0, and 0 plus 1, it means address 1. On the second address, I'm having these other bits, which are these ones. And these are locative bits. It means, by locative, it means the location of the bit. This is how I was thinking about it, and I was right. And I've seen this way of manipulating binary addresses and binary data before. This is not the first time. So that's why I'm showing you, probably you will learn something from all this movie that I'm showing you here, the mentality that I catch it up a long time, and this is from very old times actually, and it's very easy to implement, very easy to try. This was actually my first try, and it worked like that. And I kind of I was lucky, in a sense. I was kind of lucky by using it and actually make it work like this. My friend from Arduino, he wasn't thinking like in these parameters. He was thinking a bit more complicated than what I write here, and he was on the point to tell me that I'm wrong. But when I told him that it's working, he didn't say anything. Like I said, these are locative bits, so it's very extremely easy. Let me actually zoom in. So you see, this bit here, it represents this bit here, because we are on the second row here on address 1. This bit here represents this bit 3, you see. This one represents bit 1. So if I want to make a number with all these bits, I'm literally looking here on this diagram, on this naming. This is segment A, B, G, C, D. And I'm having already, I deciphered where these are. And if I want to make number 4, I'm looking here. I need F, G, B, and C, okay? So B B and C are these two bits in the middle, this. So A needs to be 0. So I leave these two, A is 0, so it's number 4, B and C. You see, B and C are 1, 1 here. This is what it means, locative. It's the exact location in the address here. So these two bits is B and C, these two. We need F and G and the rest of F and G 1. So F, this one, and G, this last two ones. So these two ones here and here, bit 4 and bit 3, it means G and F. And these first two, D and E, are 0. So these ones are 0, 0. So this is number 4 on our digit. This is how you are locating the bits and addressing to them and using them. Let me undo back as it was before, because I will make a demonstration with all this code here later. So this is what locative means. It is impossible to show you the entire history, the exact history, how I managed to figure out everything, unfortunately. But from what I'm explaining here, I hope it's making sense. And I hope is easy to understand, is more easy to understand than reading that awful PDF that is explaining with half a mouth what everything is and is more complicated than it should be. Okay, so if I want to show only one single segment, this was actually here. This was the work that I did yesterday, the entire day, to figure out how to lit up individual segments. Only segment A, only segment B, only segment C, and so on. That's how I managed to figure out where are their locations, and also their address and what digit number it is, everything. I use this original file, this one that is having this library that was working last time, and with it I run it, and I could drive my LCD from it. So in the very beginning, the very start, yesterday when I started everything, I rerun this program, seeing it performed like the last time, like the last year that I use it. So it worked perfectly, and I could confirm that all the links, all these links that I was having on my breadboard there were correct. I could confirm that the links from this chip to the LCD are they didn't move, they didn't fuck up. So this was a test program for the very beginning when I started everything, and when I was starting to discuss this problem of BitBanging with the guys on Arduino forums. So that's what I told them. It's good to have a starting program, something that you can rely on, something that you can confirm that everything that you are starting with is working properly. That's my point of showing you this. All right. All right. So this is the actual setup, what I'm having here. I'm having this wire chassis that I created to put my phone like that on it and to film what it is going on there. I hope you can see when this is actually writing the code there, those LEDs will flicker. And here, when I will make the code, you will see the changes on that display. Let's actually run with what I'm having here. Actually, let me undo back. So right now, with this code that I just explained here, we should see a number 4 there. So let's see, upload. And there is sending the program. There it is, number 4. Actually, check this out. I don't need to loop anything. I can actually leave it here only in the setup part because I'm not blinking anything yet. I will show you some test programs that I did when everything is running and moving. But for now, we need everything to not move and only to just stay there. And it's perfect to only initialize it first here, and that's it. We don't need to loop anything. So this looping, it will remain blank like that, not doing anything, okay? This is actually how I started everything in the very beginning, using only this setup function, and I was trying very slowly and with very small steps, like step after step, very small, and very length and very slowly. I build up. I tested and built up and added and commented and corrected the code until I figured everything out. I got back and I believe this is number 8. No, this one as well should be like this. This is number 8. So let's upload this one now. I'm sending its data, and from 4 it's changed in 8. Now let me show you the starting point when I started everything. When I didn't know, but right now we actually know which bits, what segments are, because I discovered them. But back then I didn't know anything. So let me comment out this one and send data. Like I said before, let me give you here. Let me turn you back here. You see this send data. This send data function, the internal of it, it's is the golden. Literally the golden function that I use it everywhere, and it's just perfect. And without this code that I had it from my friend, I couldn't manage to progress and to build anything. Many thank you to my friend from Arduino, because he initialized everything, the entire code. So right now, like I said before, this will actually render each segment on this LCD digit. So let me change this with address 0, because we are having here address 0. Here on this side, here this 0, it means address, and here is the data that we are sending. And that, like I said, is a locative bit operation. where you are actually finding the bit inside the address, memory structure address, and you are just playing with it, and you will see it in a second. So right now, if we are making all this to 0, we are only having these 4 bits, like you're saying here. So when I'm lighting up this bit 4, it will lit up only the segment A. You see, this will represent segment A, like that. So let's burn it. Let's upload it.
And there it is. And you can see it here. You see it here? That's the segment A.
Okay. All right. All right. And now let's lit up only segment B, which is this segment here. So let's make this one and this one 0. So right now we will see only this segment from this digit lit up. Let's upload it.
Programming, and suck. You see, this guy lit up.
And we will do everything. This one 1 and this one 0. So right now we will open up only this segment here. Upload.
Suck. Right on money.
Okay, next, like I said, we are only having these 4 bits here, and that's the entire address structure for address 0. That's it. That's no more than that. Now we have to switch to address 1 and to command the rest of those other 4 bits that this digit is composed from. So right now we are changing address from 0 to 1 here, and we are starting again. Let me actually copy this from here and put it here. We will do it from 0. So if we are doing it, actually if we are doing it 0, 0, 0, and also for the ABC, also for address 0, if we are putting 0, we will have a blank LCD. So that's my reset or my clear method. That's what it's doing. It's putting everything to 0 pretty much. That's what it's doing. So if we are now uploading this code, we will see a blank
LCD. So nothing will lit up there. As you can see, nothing
is lit up. All right. So next, we will open this one, which is F. As you can see here, is this bit is in this address 1 here. This square represents that segment. And let's upload it.
Programming. Ta-da, that's F.
Okay. And this is 1. This is we will reset that, and we will change this as G. So it will lit up only this one in the middle. Upload.
And it will be there. There it is. This is
the middle one. And this is A and D. So let's see. 1, 0. It will be this A. Upload.
There it is.
Mr. Segment A, exactly as I told you. And Mr. D, 1, 0. And now I'm activating this last bit here. Well, it's the first bit. Well, the last one doesn't have an order actually. It doesn't mean that this is bit 1 and this is bit 4. It might be this is bit 4 and this is bit 1. It doesn't really have an order. It's just like a group of rocks, and you are moving those rocks forward and backward. You know, it's like playing with a couple of rocks. They don't have actually a number. That's what is important to remember from Mr. Q12, your favorite artist electronist here. All right. So this last one is this segment D, which is this one, is on this bit in the memory structure. And let's upload this one.
There it is.
I finished all this demonstration where I'm showing you bit by bit. This is literally bit banging when I'm sending bit by bit commands and also lighting up specific segments of the LCD through this bit by bit functionality. To lit more than one single segment, you can use it like you are saying here. If you are using in this form, you are actually lighting up all these 4 segments. So they mean D, E, F, G. So which is D, E, F, G. So it's this side here. And this top, if you are activating these 3 bits, you are lighting up A, B, C, like letter 7. Actually, it's exactly what I used when I build my numbers. Exactly, I cut off this line and I leave it like that, and I formed letter 7 and letter 1 with this, which one? Without A. So like this. This is number 1. And let me window back. And now let's go to digit number 2 and open up 1 or 2 segments there to actually see this in practice. And imagine how long and how frustrating and how hard it was to actually figure out everything that you are seeing here, because nobody showed me anything. Nobody, not even those guys from Arduino, they didn't show me anything. I had to discover everything that you are seeing here. They only show me the door, the entering door, to how to BitBang stuff, the starting point here, all these functions, these 4 very important functions, and that's it. They have all my respect for that part. But after that, I had to really put my brain in function and to to ramp up the engines and to actually do the work of discovering everything. So right now, let's do a little bit of digit 2 to actually show you some bits inside it. So like I said, we will jump to right now to address 2. So this address 2, and if it's address 2, it will be this ones, CBA. So if we are lighting up B, so 10, so 0010, so 001 B, it will, this one in the middle here, it will lit up, and let's upload it.
And here it will be, and there it is.
And actually, let's change to F there. So let's send another dude here. This will be on address 3 because it's the F side here. And let's see, F is the first one. So these other ones are 00. We can leave this B here, or we can close it. We can leave them both open, and we will see on B and on F two segments open, and that's it. And the rest off.
So this one will remain open, and another one will open there.
And let's see what we can do next. We can open up A and G. And let's do that. A, it's 1 here, and G is here. No, this one, 1. Yeah. So we will have a little square on the top. A, B, G, F. A, B, G, and F. Right? So upload.
So here we will have a little square, or half of an 8.
Okay, and let's do the digit 3 part. And it's the same procedure. We are following here, address 4, and address 5. And I will leave the same code. So this little circle from here, A, B, G, F, will jump here on this other place. And let's upload it.
And from here it will jump there.
And that's it. So you see, you've seen all 3 digits that I specifically address them, and I literally BitBang them. And the next step is actually to make some numbers to make them move here in the loop, or just to print them and then to make them move. Yes, this is it for this very basic, like I said here in the beginning, this most basic segment driver that is a little bit, I don't know, it's having a little bit of code in the beginning, but after that it's very, very easy, extremely easy to use, and that's what all is all about, you know, to be easy to be used. And okay, let's open this other guy, and I close that, and I'm opening this. So you see, made by Q12 and Rintin. So this test code will write 0 to 9 numbers on all 3 digits, and is exactly what I wrote here, but a little bit more complicated than that, because I will actually make them move. So right now I will show you a brief. I will go through all the functions that I'm having here, and I will show you all the codes that are making everything. So this here are the beginning code from my Rintin original codes to actually make all this stuff BitBang correctly. So this is the beginning code, and from here down, here is like before, this address array. This is the segment array, and this is the clear function. Like I said, it was way more nasty than it is right now. This is very, very specific and is more performant. This is the best clear function that I could think of. This is where I'm creating the actual numbers. Like I told you before, I'm using only this line here. I don't need 2 addresses. I only need one single address for number 1. This is number 1. This is number 2. And you can follow these bits, and you can find them here. As you can see, A and B. So A and B. This is a 2. A, B, G, A, and D. And here on the second is G, A, and D. No. So you see G, A, D, G, A, and D. And F is blank because F is not used. So this is the number 2, and number 3, and down to number 0, which is the last one. And then I made a H. I leave it as number H, but it's H from high and low. When you have higher and lower, logic levels, high and low signals. And I made this only letter H here. This is only letter L. This is E, an O letter, and you will see them all in practice. And this is the first function, blinking 1 to 3. This is the very first code to lit up all 3 segments with 888 in the very beginning, and to see if it's dimming, if the contrast is good enough. And it was very good. The contrast, it was normal, a normal contrast. I didn't have any diffuseness. This is a bunch of counting tests, counting A, counting B, but it's good to see the code how I use the code, the structure of the code inside it. And this is an update function that is used inside this counting test A. This was the last program or test, counting test, actually to actually make it working. I didn't know how to make it work. I wanted, like you can read here, example of counting 0 to 9 on all 3 digits, digit 1, digit 2, digit 3 at different speeds. So this was a very tricky challenge. I had no idea how to do it. So last night and today in the morning, I only stay on this problem. I probably spent 10 hours only on this motherfucker to make it work. In the end, I realized I got an idea that all these displays are used as clocks to display hours, minutes, and seconds, right? So I thought from this perspective how you can actually display some numbers at different speeds like a clock. So following this idea, with this idea in my head, I actually managed to make all this code. As you can see, here is the function, this update function that I created it here, this one here, and is doing all this mambo jumbo inside here. And it was quite difficult. Like I said, 10 hours, and I made like 40 versions of coding. Or probably more. I tested a ton of shit, and I couldn't really figure it out. And in the end, it boiled down to have all these 3, like you are seeing it here, digit 1, digit 2, and digit 3, all 3 digits on the same line, to display them in the same time, and then to count them one by one and to change speed for each. I don't know how to explain it better than this. This is commented out. This was the original idea. And then I transform it into this one. So it's the same thing what I'm having here, but it's included inside it here. And then a high-low test that I told you before. Test advanced. This is advanced. And this is the setup. Like before, is only containing this configuration that is used in the very first functions of the code, and a clear to prepare for the loop. And that's it. And inside this loop, I'm having all these functions, comment them out. And I can uncomment one and show you right now how it's actually how it's working. So let's get through all of this and show you what I made and how it's looking and how it's performing. And remember, everything you are seeing here is BitBanged. With literally, I'm manipulating the bits, each bit individually, literally. And it's pretty awesome, and I'm very, very extremely proud of this achievement. All right, let's run this first. Blinking 1 to 3 is not fantastic, but it's telling. It told me that it is running correctly, all these 3 digits together. I can change it to 888 if I want, but let's run it as it is. So right now I'm uploading it.
And here we will see a blinking 1 to 3. You see? 1 to 3, and it's blinking.
Again, these are test codes that were telling me how to progress with my code and how to understand better what I'm working with. This is another test code, counting test A. This idea of rotating numbers with different speeds, it started with counting test A, but I couldn't actually make it up until test A. So all these are failures, but they are interesting failures because I attacked the problem from different angles, let's say. So let's see how counting test A is performing. So upload.
And it's uploading. Okay, so right now it's numbering like this, and I believe it will jump. No, this is just a simple, one single counting digit.
So this was the simplest counting digit. All right, let's do this. Test B, let's upload it.
Okay. What this program will do, all 3 digits are counting in parallel.
Again, nothing fantastic, but I was progressing. I was targeting what I wanted to do in the last working in this last A version. So this test C, let's see, upload.
And it's programming right now. It stopped a little bit. Yeah, you see how it's counting. And this is faster, this is fast, and this is slow, or normal. Normal, fast, and very fast. This is doing it extremely, it's still showing the correct number, but very, very quickly. And this, you can actually see it here, and this is with a little bit more timing.
Okay. And this D version, upload.
Yeah, you see it's jumping from here to here and from here to here. And this is very fast, and this is normal.
Pretty interesting, right? All right. Again, with all these previews functions, I wanted to actually to achieve this last one that I'm having it here. And I managed to make it.
And now it's uploading. And this is what I envisioned from the very first function. I wanted all this stuff that you are saying here exactly, well, not exactly like this, but this is very close to what I was thinking. I was thinking a little bit more complex, but I believe the code that I'm having it here, I can move around some pieces of this code that is already doing this, and I can obtain that kind of a random speed, transition of the numbers. It was a funky idea, but this is working exactly like a watch, like a normal clock at this point. And as you can see, all the numbers are having a very good contrast. It's perfect actually. I couldn't ask for better. And this is the high-low test. You will see a H and the L that are switching back and forth. You see H and low, high and low, pretty much. And let's see. And the last one of the functions. The last function is actually writing high and low. You see, high and low. You remember this little circle that we made on the top, here in the middle and there. So that's the code. It's literally bit banging and doing whatever the fuck you want. This is the freedom. This is the liberty that you can do whatever the fuck you want by manipulating directly all the bits, the individual segments of the LCD. This is fantastic. Now I'm very happy, more happy than when I was using that specific library that was dealing only with numbers and that's it, not specific segments like I'm doing it here. That I can construct whatever shape I want. I believe I touched everything. If I didn't, I will come back and I will make another movie probably. But pretty much that's it for this. I hope you liked my experience. I hope you learned as well as me, or better said, along with me, you learned how to do this thing yourself and actually use whatever LCD you can find. This one is brand new, what I'm having here, but I'm planning to actually drive some used LCDs from God knows where, and I will make a better setup than what we are seeing here, and we will see after that how versatile all this thing that I built here is practically is. So yes, thank you very, very much for watching and for staying and listening and understanding what I just explained. And thank you very much, and see you later with the next update, with the next movie of the truly great Q12 empire here. All right, thank you very much. See you later, and we will discover new and adventurous new things in the future. Bye bye. Bye bye.